kids. Today we are going to conduct a very special scientific experiment called the dancing popcorn.
First, let's prepare our ingredients: water, vinegar, baking soda, popcorn kernels, and a glass jar. Start by pouring water into half of the glass jar, and then add 2 tablespoons of baking soda. Stir the mixture well so that the baking soda dissolves completely into the water. Next, we will drop a small handful of popcorn kernels into our prepared mixture. Now, carefully and slowly pour the vinegar into the jar and watch what happens next.
Look closely. Carbon dioxide bubbles are being created from the reaction between the vinegar and baking soda.
These carbon dioxide bubbles attach to the popcorn kernels and act like little life jackets, lifting them up. The bubbles pop at the surface, making the kernels sink before they catch more bubbles and rise again.
Welcome to our Grand Science Marathon. Today, we are performing 20 incredible experiments you can try at home. We start with a classic. Experiment 1, the baking soda volcano. Let's see how we can create a safe, bubbly eruption. You will need a bottle, baking soda, some red dye for the lava effect, and common white vinegar.
First, place your bottle in a tray. This will be the base of our mountain, preventing vinegar from spreading everywhere.
Pour about 3 tablespoons of baking soda into the bottle. Make sure it reaches the bottom of the container clearly. Now, add a few drops of red food coloring to make it look like real molten lava when it erupts.
Here comes the trigger. Watch closely as I pour the vinegar into the bottle to start the chemical reaction. Look at that. The carbon dioxide gas is expanding rapidly, pushing the foam out of the bottle like a real volcano. The reaction between the acid in vinegar and the base in baking soda creates this amazing, harmless, erupting foam.
Hello everyone. Let's explore the bean seed germination experiment to understand the cycle of life.
Preparation: bean seeds, a small plate, cotton balls or paper towels, and some clean water daily.
Place the damp cotton on the plate. Then scatter the bean seeds on top of the cotton.
Place the plate in a spot with gentle light and always keep the cotton moist every day.
Observe the process as the bean seeds begin to crack open, grow roots, and send up their first green shoots.
Record the changes in size and shape of the bean sprouts each day as you do the experiment.
The result is that those tiny bean seeds have grown into incredibly strong and beautiful young plants.
The seed contains an embryo and a stored food supply to begin an entirely new life cycle. Water and the right temperature are the factors that activate biochemical reactions for the sprout to emerge.
The experiment brings joy as you witness the beginning of a new life with your own eyes.
To make safe and colorful toys at home, you will need gelatin powder, various food colorings, and creative silicone molds. These items are easily found in your kitchen or at any local store, making this a perfect DIY project.
First, start by pouring 75 ml of water into a small pot to begin the base of our colorful toy mixture.
Add 3 sheets of gelatin along with a sufficient amount of your favorite food coloring to give the toy its hue.
Stir the mixture thoroughly over low heat until the water and gelatin are perfectly blended into a smooth, colorful liquid.
Keep the heat low and watch closely until you see the mixture start to thicken and develop a gel-like consistency.
If any bubbles or foam appear on the surface, gently skim them off to ensure your toy comes out clear. Now, carefully pour the hot mixture into your chosen molds, filling them right to the top for the best results. Repeat the entire process using different colors to create a diverse and vibrant collection of fun, squishy toy shapes. Once your molds are filled with various colors, leave them to set and dry for about 1 to 2 days.
After waiting patiently, you will find that the mixture has transformed into adorable, firm, and incredibly cute toy figures.
These homemade toys are not only fun to play with,
but are also completely safe for your health and the environment.
Hello everyone! Let's explore the soil types experiment to find out which soil is best for plants. Preparation: 3 soil samples, the sandy soil, clay soil, loamy soil, 3 funnels, and 3 cups of clean water.
Place each soil type into funnels lined with cotton. Then pour equal amounts of water onto each sample.
Measure the amount of water that flows into the cup below and the time it takes for water to pass through each soil type. Use your hands to feel each moist soil sample to notice texture, stickiness, and ability to hold shape. Compare the results from the 3 soil samples to draw conclusions about the physical properties of each type. The result is that loamy soil holds water best, while sandy soil allows water to drain through very quickly.
The size of soil particles directly affects water holding capacity and soil aeration. Soil that has a balance between water retention and drainage is the ideal environment for most plants.
This experiment helps you learn how to choose the right soil for each type of plant in your home garden.
Hello everyone! Let's explore the hand bacteria experiment to see the importance of hygiene.
Preparation: 3 fresh slices of bread, 3 clean zip-top bags, and some antibacterial hand wash.
Touch the first slice with a dirty hand, the second slice with a water-washed hand, and leave the third slice untouched.
Place each slice into separate zip-top bags, label them clearly, and keep them in a warm place. Observe the growth of mold and bacteria on each slice of bread after about 1 week.
Compare the level of spoilage between the slices to see the difference in bacteria present.
The result is that the slice touched by a dirty hand shows the most mold compared to the others. Our hands contain many harmful microorganisms that are invisible to the naked eye. Washing hands thoroughly with soap removes disease-causing agents and protects your health.
This experiment is an important reminder about maintaining daily personal hygiene.
Wipe down your plate and get ready. Next, we are going to explore the world of secret messages and spies. Experiment 3, invisible ink with lemon. We are going to write a secret message that only heat can reveal. Experiment 3, invisible ink with lemon. We are going to write a secret message that only heat can reveal. You'll need half a lemon, a small bowl, a Q-tip or a paintbrush, and a sheet of white paper.
Squeeze the juice into the bowl. This juice contains organic compounds that will turn brown when they are heated up.
Write your secret word on the paper. At first, it will look like you are just painting with plain water.
Let the paper dry completely. Once it is dry, the message becomes invisible to the naked eye, hidden from everyone.
Now, apply heat using a hairdryer or a safe light bulb. Be careful not to burn the paper during this.
Look, the letters are appearing. The heat causes the citric acid to oxidize and turn brown, revealing our secret word. It works perfectly. You can now send secret notes to your friends that can only be read with a heater. Oxidation is the process where a substance changes when exposed to heat or oxygen. It's the same reason apples turn brown. That was successful. Remember to clean up your station before we move on to our second magical experiment today. Experiment 2, magic milk. This experiment explores surface tension using simple kitchen items and some bright, vibrant colors. Gather your milk, some dish soap, cotton swabs, and at least 3 different colors of food coloring for this.
Carefully place drops of different food colors in the center of the milk. Try to keep them close together.
Now, take a cotton swab and coat the tip thoroughly with dish detergent. This is our secret chemical trigger.
Watch what happens the moment the soap touches the milk. the colors immediately begin to race away and swirl.
It looks like a moving painting. The soap is breaking the surface tension and chasing the fat molecules in the milk. You can keep moving the swab around to see how the colors continue to react and form new, complex patterns.
This demonstrates how detergents interact with fats. It's not just magic, it's molecular science happening right in front of you.
Surface tension is like a skin on the water. Soap breaks that skin, allowing the colors to flow freely everywhere.
This experiment is completely safe for children. It helps kids learn how acetic acid in vinegar spectacularly dissolves eggshells.
Step 1. Prepare a large plastic or glass jar big enough for the egg, a bottle of white vinegar, and 1 raw egg.
Step 2. Place the egg inside the jar, doing it gently so the egg does not break.
Pour the vinegar into the jar, leaving about 1 centimeter of space at the top.
Then put the lid on, but do not tighten it so that gas can escape to the outside. You will immediately see small bubbles forming. This is the chemical reaction starting to work on the shell. Step 3. Leave the jar for 3 to 4 days. Patience is key to seeing the magic happen. Over the next few days, the acetic acid will continue to break down the calcium carbonate in the shell. After that, you take the egg out and rinse it gently under clean water. And you have seen the eggshell has miraculously disappeared, leaving only the soft inner membrane. It is very simple, right? The egg is now bouncy and translucent, almost like a little ball. You can do it right at home so you can observe it day by day and learn about science.
Hello everyone. Let's explore the plant light-seeking experiment to see the cleverness of plants.
Preparation: a small cardboard box, cardboard dividers, a small bean plant, and tape. Create a maze inside the box using cardboard dividers and make a small hole at the top of the box. Place the small bean plant at the bottom of the maze, then close the lid so light only enters through the hole.
Water it fully every day and wait to see how the bean plant grows in the darkness.
After 1 week, open the box and observe the growth direction of your small bean plant.
The result is that the bean plant found its own way through the maze to reach the sunlight. Plants tend to grow toward light sources thanks to the effect of growth-stimulating hormones.
Light is the essential energy source for plants to perform photosynthesis and sustain life.
The experiment helps us understand the adaptability and natural reflexes of plants.